7-18, and we'll take a look at 717. So a normal distribution has a mean of 50 and a standard deviation of 4. So I've plugged those numbers in there, and what we're going to be doing now is oftentimes determining, as it says in A, compute the probability of a value between 44 and 55. So remember, my mean was what, 50. Okay, but what I want to do here, and this doesn't really allow me to do this real well, okay, but 44 would be 1.5 standard deviations, and we'll look at that. So I'm going to add, right, this amount basically, okay, to my other one, because 44 would be a negative, to 55, which is a little over 1.25 standard deviations. We'll do the math, but okay. So I'm going to add those two values together. So from here to here, basically in that neighborhood, and I need to add those together. So 43 roughly, and 37, right? 30, yeah, it's a little more than that, and 40 or close to it. Okay. So what am I going to be? About 83%, somewhere's in that neighborhood we can kind of take a look at. Okay, but let's do the math. And first we find our z values, and so with probability of the 44, so again it's simply equal to my parentheses, my x in this case, which is 44 minus my mean divided by my standard deviation, right, minus 1.5, and I do the same then for this one, which is a positive. Okay, and those give me my z values. So again, we can look up the z values, and this one's minus 1.5, and we'll do that. And you guys can do it in page 732 as well. But for the first one, which is minus 1.5, we're right here, right? So 0.4332, okay, which I can input in there, and then my 1.25, okay, to the plus. Okay, and we'll look at that chart again. 1.25 is 0.3944. 0.3944, and again, remember, this means that this is to the left of the mean, 43%, and this is to the right of the mean, 39%, and I want to figure out what's in between there. So if I look at the chart just like the one on page 222, I'm adding those then, right? Okay, so there's an 82.76% chance that I would pick a value randomly, that I would pick a value that would fall between those two values. Okay, then moving on to B, it says compute the probability of a value greater than 55. Well, 55 we had. Okay, and my z is 1.25, and again that value we already have up here. Okay, but I'm gonna do a value that's greater than that. Well, how would I calculate that? Well, again, this is to the right of the mean, 39.4%. Okay, and I want to go to the right of that. Okay, so I know that I have the whole left-hand side, right, of my normal distribution, which is equal to 0.5, and 39.44% to the right gives me a 0.8944. So again, if I'm looking at that, and looking at that how we would do it here, okay, so what was I, 1.25, 0.8944, okay, but I want to know what's that area that's to the right of that. Okay, so the light blue area that's still under the curve, I want to know what the area is to that, and this actually lets me do that. Okay, 10.56, and I can calculate that like this too. I can just say that this is equal to 1 minus my 0.8944. Okay, 10.56 then, is the percent. Okay, then lastly it says compute the probability of a value between 52 and 55. So now both of these are to the right. Okay, both of these are to the right hand side. Okay, and I'm looking at a value that's in between those. My little handy dandy favorite tool isn't going to really let me do that, right? Because I'm going to be to the right, what, about a half of a standard deviation, so somewhere around here. Okay. And then I'm going to be a little more than a, 1.25 standard deviation, so 0.30 to here. And so I need to know, and again, I can't really show you with this one, but I need to know the area roughly between here and here. Okay, and I do that this way. Again, I do my calculations, and I figure out what my z value is, 0.5. I looked that up. Okay, and that says that I'm 19.15% to the right. Okay, and for 1.25, I'm 39.44% to the right. But remember, I want to figure out what it is between those, and so I simply, in this case, subtract one from the other, and I end up with a 20.29% is the odds that I would have that I would pick something between a 52 and a 55.